Hey everyone, welcome to MindMajix YouTube channel. Are you ready to explore the dynamics of SQL data analytics in real time? This MindMajix tutorial is not just like another boring lesson. It is going to be your gateway to mastering data analysis with real-world, hands-on examples that keep you engaged every step of the way. Getting started from the scratch, you get to create your own database, design data tables, insert meaningful information into them. Take your first steps into querying, learning how to ask questions to your data and get instant answers. But why stop there? SQL's true magic lies in advanced techniques. Master joins to connect data from multiple tables, create temporary tables for quick experiments, and craft views to simplify complex queries into reusable insights like a pro. Like I said, this is not just a tutorial. It is an interactive learning real-time use case adventure tailored for every skill level. With these step-by-step demonstrations, you won't just learn SQL. You will feel the excitement of solving problems in real time. Each concept is linked to practical use cases, so you are not just learning the theory, you are applying it right away. And here is the best part, this is just the start. More case studies, challenges, and deeper insights await. So grab your seat, let's make SQL your secret superpower. If these are the type of videos you would like to watch, then hit that like button, subscribe to our channel, and press the bell icon. So without any further delay, let's get started.
In this session, we will learn the SQL fundamentals. So we decided to divide the SQL fundamentals into 8 to 10 case studies. As the saying goes, tell me, I forget. Teach me, I might remember. But involve me, then I learn. So we believe in that statement. So that's the best way to learn, or that's the best way to teach someone, making them involved in a case study, making them involved in the practical demonstration, right? So that's why we have come up with teaching the SQL fundamentals through the use cases. So we will be lining up these use cases in 8 to 10 sessions. So this is our first session. And the first session is about a case study about someone named Danny, and he owns a diner. Let's say in the business terms, you own a restaurant, or you own an inventory, or a showroom, or anything which revolves around the business. For the instance, let's go with Danny's Diner. So Danny owns a diner, and he has a couple of customers, and he has a couple of premium members, and he also has a couple of recipes on the inventory, right? Now, he is someone who is focused on growing his diner into multiple franchises in multiple locations, maybe even out of the countries, right? To get to that heights, he needs to plan accordingly, right? So he needs to understand what is the most convincing factor about his diner for the customer to get a membership, or what is that favorite item or the most selling item or the most important secret recipe of his inventory which makes the customers go crazy and order them multiple times, right? So this is something sounds like a business case study, right? So let's look at the data and understand what exactly is going on here. So this is a problem statement. Danny wants to use the data to answer a few simple questions about his customers, especially about the visiting patterns, how much money they've spent, and also which menu items are their favorite. Having this deeper connection with his customers will help him deliver a better and more personalized experience for his loyal customers. He plans on using these insights to help him decide whether he should expand the existing customer loyalty program. Additionally, he needs to help to generate some basic datasets so his team can easily inspect the data without needing the use of SQL. Danny has provided you with a sample of his overall customer data due to privacy issues, but he hopes that these examples are enough for you to write fully functioning SQL queries to help him answer his questions. So we are trying to involve you, the viewers, to solve this problem of Danny. So this is the problem statement, and he shared a small chunk of his entire dataset so that he understands that this is a SQL query, and this can help me out to run it through all the datasets that I have and get the exact row or exact entity that I'm looking for, right? So this is his idea. So he gave us 3 chunk of datasets. So a part of the sales data, a part of the menu data, and a part of the membership, right? And scrolling further, we have the entity relationship diagram. So if you have multiple storages or multiple places where the data is stored, or multiple data sets or multiple data tables, and you want to connect them all, and it's like a puzzle, pieces of the puzzle, and if you want to unite all the pieces of the puzzle together and make something meaningful out of it, that's when you get to the entity relationship diagram. So that's when you collect all the data tables together and try to establish a one-to-one connection, or one-to-many connection, or many-to-many, or the opposite, which is many-to-one. So this is something a little bit complicated, so we have a dedicated tutorial for that. We will be linking that in the description box below, where you can understand the ER diagrams in a much better way, and what exactly are these one-to-many, many-to-one, many-to-many, and the one-to-one relationships, right? So here, for a single instance, here you can see the first table, which happens to be the sales table. Here we have customer ID, order date, and product date. So here, sales table is having many-to-one relationship with the customers table. The star logo indicates the meaning of many, and one indicates one, right? And here it is also having a many-to-one relationship with the menu data table, and menu is having one-to-many with the sales. Similarly, member is having one-to-many with the sales table, right? Now, moving ahead without any further confusions, let's proceed with the example datasets. So we have a chunk of the sales data, not the entire sales data. So even the customer data is masked here. So the customer ID is mentioned as ABC, and the order date, it is 2021. So it can be from the past, it can be from the future, or it can be a prediction what could happen in the future, right? So as discussed in the problem statement, due to privacy issues, Danny has provided you with a sample of his overall customer data, right? So you just want to just work it out and give him some queries so that he can just copy and paste the queries in his real-time dataset, where he will get the data he's looking for, or the information he's looking for, right? Proceeding ahead. So this was the first data table, which is the sales data table. Proceeding ahead, we have the menu data table. So here he mentioned a couple of product names, and the product ID is just 1 to 3. And in the names we have sushi, curry, ramen, and some price tags for it. And followed by that, we have the last table, which is about the premium members. So even the customer ID is AB here, and the join date, which is some imaginary join date, which might be the subscription date to the premium membership. So this is all about the data, and proceeding ahead, we have the interactive SQL session, right? So he has provided us with some codes to create a data table, and some queries to insert the data into the data table. And apart from that, if you proceed ahead, we have the case study getting started. So here we have about 10 questions that Danny is looking answers for, right? So these are the 10 problems that you need to solve for Danny, and provide him the SQL queries which he can use and implement the same on his data to extract the valuable information that he is looking for to expand his franchisee, right? So this is our case study questions. Let's quickly copy all these questions and go back to MySQL workbench. So we are on the MySQL workbench here. So just copy and paste it here. And if you see the thing, it's not taking it the way it needs to take it. So what we will do is just quickly mask them off. So you can mask the queries in MySQL workbench using the double hyphen, or you can also use the slash star at the beginning and slash star or star slash at the end. That makes it as a comment, right? And now we have one. Okay, let's comment it first and then the first query. Similarly, let's comment all of these. So there you go, we have added all those questions or queries here. So before we begin with answering all these queries, we need to build the datasets and we need to enter the data provided by Danny, the sample data, into those datasets or data tables. Right, so there are two different ways where you can add data into your SQL workbench. Firstly, you either manually create a dataset, which is using these codes that he provided with us, which look something like this. You can use the create schema first, right? First you create a schema or a database. So remember, schema is also named as a database. So create a database or schema with a certain name and then set a path to that, and after that you create a table. So create and table are the keywords. Sales is the variable name or the data table name. So customer ID is the first column, order date is the second column, and product ID is the third column, and here you have some data sets, correct? So this happens to be the old school style of creating data sets. If you have a really short data like the ones we have here, then you can proceed with this sort of approach. But imagine if you have about thousands of rows of data. Would you like to write thousands of lines of query for that? No, right? So let me also tell you one certain way where you can just import the data as it is from the source. For example, in our situation, we already have three tables: members, sales, and menu, right? Let's say I want a new data table. Then what I do is I just create a new schema. Here, I will select the option create schema. You can just right click and you'll get that option. Create a new schema, and let me name this new schema as Danny's Diner. So we already have a Danny Diner. So let's keep it as Danny's Diner, or maybe Danny's Diner 2, and just apply. You have this particular window popped up. Just apply, apply, and finish, right? You have a new Danny Diner 2, and you can close this up, and maybe even you can have a new query window, new query tab, and here come back to Danny's Diner, and here you have no tables, right? If you go to the first Danny Diner, here you have some tables, right? You have a drop down option, but in the second one you don't have a drop down option, which means this database is completely empty. So now you just double click on the schema here, or you can right click, or do anything so that you get this option or set of options here drop down. You just go to the option table data import wizard, and then you can browse to the profiles where you have the data set. So here I have some data sets here, so you can just click any of those and just open up, and the data will be loaded. Next, and you have the next option again, and you just check all these data types. You have a small mistake here, order ID, right? It's taking a different name. You can just always use the alter table command and change the column name here. And next, and next. This might take a little while, not a problem. Next, and finish. Right now, you can just refresh the schema and you have something in the Danny Diner. So the thing is, we did not actually import Danny's Diner tables. I just showed you how you can create a schema and you can just directly import the data onto your schema without having to build anything manually, right? Now you can just copy this particular name, or you can write down here, use database Danny's Diner 2, control enter, and select star from dealership data, control enter, and there you go. So you have order ID, order date, and all the entries that you're looking for, correct? Now we don't want to work with the Danny's Diner or dealership data. We want to work with the first schema, which happens to be the Danny Diner. So this was a practical demonstration of how to utilize the import data wizard in your SQL workbench and directly import the data for your real-time usage. Now let's quickly remove this drop schema and drop now and done. You don't have Danny Diner anymore. Close this window. We don't want that anymore. Don't save. And now we're back into the business with Danny Diner, right? Now, before we get started with solving all these queries, we need to access Danny Diner first. For that, the same query, Danny underscore Diner and semicolon, control enter is a shortcut to execute your commands on MySQL workbench. Now you are, repeat, and now you are in Danny Diner schema. Now let's proceed with having a brief look at our data sets. Firstly, select star from, select everything from members, and next would be, why don't we just copy and paste this right here to save some time. And again this one, so in place of members we will have menu and sales. So if you closely observe, let me expand this window a little so that the letters are a little more clearly visible. So you can also minimize this particular length for better clarity, and this one as well. You can leave me a comment here to know the best way to hide this, or we can choose this particular template. There you go. So I think this is clearly visible now. So let's run this query and we have an output. So we have A and B in our premium membership table, and if you run this query we will have the items which are mentioned in the menu: 1, 2, 3, sushi, curry and ramen. And after that we have ramen or ramen, the way you call it. And lastly we have some sales data, which is A, B, C, right? So we have A, B and C. So the customer's name is not specifically mentioned here, remember, due to privacy issues. So this is the data we have, and now we can proceed with the execution of each and every one of these case studies and come up with an answer for Danny's questions. So the first one happens to be, what is the total amount each customer spent at the restaurant? Now for this query, Danny is trying to understand all the customers' data, right? He wants to specifically address each and every one of his customers, and he wants to understand who spent how much of the amount, right? And out of that he can, order that by descending order, so that he can identify who was that one customer who paid or who made a lot of sale to his restaurant, right? Something like that. So basically we want customer name and the amount of money he spent. So if you take a closer look in the customer table, we don't have everything that we needed, right? In the sales table we have customer ID, order date and product ID. But if you go back to menu, you can have the information about the price. Now this calls for a join function. Now what are you looking for? We are looking for customer ID and price. Now again, it's not just any price, it's looking for the total price. So in this situation, you call up the function or the aggregate function called as summation or sum. Now I want to select these two columns. So you go with select clause here, and from which table I want to go with the first table, which is sales. I want to paste it over here, and I want to join something here. I want to join the menu table, because menu is the table which has the details for pricing, right? If I just run this query, I'll not get the details for price because this particular sales data does not have the column about price. Now I want to join menu with sales data. on some parameters. So I'll use the keyword on customer ID, right? So let's take a look, right? Let's take a look. Let's check for that common column in between both the tables. It can be a customer ID or the product ID. Let's run the menu table once. So here we have product ID, and in the sales table we should be having one or the other common part. So here it is. We have the product ID, right? Now let's select the product ID, copy the field name, join on the basis of product ID equals to product ID. But now there can be a chance of uh, ambiguity, right? SQL workbench will feel ambiguous. Which product ID are you referring to? Are you referring to the sales table product ID, or are you referring to the menu tables product ID? So I want to make sure that there is no ambiguity. So sales dot product ID should be equal to menu dot product ID, and I think that's the end of the query. And you can also do one thing. Order by customer ID or group by customer ID, order by sum of price descending. And now let's run this query, and there you go. Now you have the details of all the customers: customer A, customer B, and customer C. And customer A happens to be the most premium customer for Danny because he spent about 76,000, or it could be 76,000, but now according to the sample data he spent about $76 in Danny's Diners, and B is the next one with 74, and C is the last one with $36 spent in Danny's Diner. So this is how you can make use of select clause, join clause to join two different tables on a common column, which happens to be in our case is the product ID, and you can group the data based on customer ID, and you can order based on the descending order to identify who's the top one. Should you go with ASC, then you will find out who is the customer which spent less in Danny's Diner. There you go. That's how it works. Now, moving ahead to the second query, we have now proceeding ahead. Danny wants to know how many visits each customer made, right? And he wants to specifically make sure that how many days has each customer visited the restaurant. He did not mention times, right? He mentioned days. So the reason being, So the reason being I'm highlighting this is, in a day you can visit Danny's restaurant. Repeat. The reason why I'm highlighting this is because in a day you can visit Danny's restaurant for 100 times, right? Or even one time. But here, Danny is more focused on learning how many days each customer visited. So again, here we want customer ID. So you can just copy this from here and kind of paste it here. And instead of sum, we want to count order date. Or if we go back to sales and get this, we have order date, right? Copy the field name, and here in place of price, you provide order date. Now, if you closely observe, here you have 2024 1 once, 2024 1 twice, and the days are repeating. Same with the number here, 2024 11th, right? So here we want to make some modification. Here you want to provide distinct, so that the workbench only counts one entry of each date, unique entry each date, and provides you with that information, semicolon. And if you kind of execute this, you get the data you're looking for. Okay, I think we missed group by, so let's also do that, because a customer can have multiple entries. So let's group by. The same as we saw in the previous entry, the same customer might have visited in multiple days. but we want to count the total number of days that particular customer has visited. For that kind of situation, we might have to group by, use the group by function here and get the answer. Now let's execute this query, and there you go. So here we have 3 customers. A visited 4 times, 4 unique distinct entries, B 6 unique distinct entries, C unique distinct entries of 2 times. Now if you want to again order by, you can also order it by ascending or descending, but again once we have learned it, now let's proceed with the next query or next question that Dan is looking answers for. What is the first item from the menu purchased by each customer? Now this seems a little tricky, but not as tricky as it sounds. Let's make use of the aggregate functions again. Select order date from menu, sales. I think we have order date, order table and sales, right? Order date from sales. There you go, we have the order dates. Now, if we want to understand the first item purchased by each customer, then we have to identify the first visit when the customer has placed, right? So for that, customer ID, comma, minimum of order date. I think there's a small error for this. Let's modify this. Yeah, we need to provide distinct because a customer ID has multiple entries. So we just have 3 customers which have visited about 10 to 15 times. So we need distinct for that. So this is how you learn. You try to make some solutions and you end up with a small problem, and then you understand where exactly the problem is and you never make that mistake again, right? Okay, so far so good, but we still find some errors. The in aggregation, okay, let's expand that. Aggregated query without group by. Okay, let's group by again. It should resolve the error. There you go. So the first date visited by each and every customer with the same date, 1st of January 2024. Not a problem. Now we need to identify on this date which was the first product, which was the first dish that each and every one of these customers bought. Now for that, we might have to make a little modifications for the same code. So we will be grouping by customer ID. Now we want the product as well, right? Which product did they purchase? So we might have to provide the product ID or product name for that. We would go with product name. And we will also make a slight modification here. Since we have used this particular product name here, we will also group by the final result or final data table with the product name as well. You'll understand why did I do that. Before that, we don't have product name in sales table, right? So for that, we might have to proceed with a join operation, and we need to join menu. And so the common point between both is product ID, right? So sales dot repeat. So sales dot product ID equals to menu dot product ID where order date is equals to select minimum of order date from sales where customer ID is equals to sales.customer ID. I think there's a small error here, sales.product ID. I think in place of full stop we placed a comma. There you go. Underscore. Missed on, right? And group by. And here we missed to close the query. Right, now it looks fine. Now let's execute this statement. There you go. So we have the table, resultant table here. So on the first day, customer A bought sushi and curry. Customer B bought just the curry, and customer C bought ramen. Right? So these were the first products purchased by each and every customer. Now moving ahead to the fourth query, we have what is the most purchased item on the menu and how many times was it purchased by all the customers? Quite similar to the previous query, but now he wants to identify which is the highest selling product and how many times each and every one of the customers bought it. So now let's begin to solve it. Now let's begin by answering the query. So we will be selecting the following names, which is product name, copy and paste it here, comma. We also need the product ID. So let's take the product ID. So we just don't need the product ID. We also need the number of times it was bought, right? So count of product ID from sales table. And we are going to join this with the menu because the product ID details are present in the menu table, right? So we will be clubbing both sales and menu using the common column, which is product ID. Product ID is equals to product ID. Now to eliminate the confusion, we will write sales.product ID on menu.product ID. That's fine to to eliminate the ambiguity. Now we will group by product name, and we will order by number of times or the count of products, count of number of times the product has been bought. We will order that by descending the most purchased item. So this might yield in multiple entries, right? We have about 3 entries: sushi, ramen, and curry. So we don't want all of that. We want the top sold item. So we want to limit the output by 1. I want 1 entry. Now let's try to execute the query. There you go. Product ID field, 1 error. Let's expand it. So this is a little ambiguous. So the product ID was from menu. So let's copy the table name dot menu here, and this should execute fine now. There you go, we have. So the ramen is the one product that was purchased by the customers at the maximum. So now Mr. Danny has the detail that ramen is the highest selling product, so he needs to fill his inventory with more of the ramen products. There you go. Now the next query, which item was the most popular for each customer? For each customer. So this is overall level. Ramen was the favorite dish on an overall level, but now for every customer there can be a specific product, right? So that's the question here. Now let's use the same approach. We can copy paste the same query here and make little modifications to it. Paste it right here. Now along with the product name, we also need the customer ID, so that we can independently identify which was the customer and what was the product ordered by him as a multiple number of times, right? From sales, join menu on sales, product ID, yeah, that's fine. Group by, since we included the customer ID, we need to include customer ID here as well in the group by command, and order by customer ID and count of product ID in descending, and we don't want to limit this because we want all of the details of all the customers, comma. So there you go, and instead of product ID we want customer ID. Now let's execute this query. Let's see if we find any errors. No, we have it. So customer A bought ramen for the most number of times, followed by curry and sushi. So out of all the purchases made by customer A, ramen was the topmost one, and followed by that customer B bought all of the items twice, and customer C bought just ramen for 3 times. So it did not show interest in any of the other items. I think ramen is his favorite item. Now proceeding ahead, we have the 6th query, which states which item was first purchased by the customer after they became a member. So this is kind of a similar query, but we have a condition here, right? If we go to the 3rd table, which is about the members table, so that particular members table had 2 customers, customer A and customer B, and they have also purchased a premium membership. It's like a subscription, right? So they want to identify, Danny wants to identify, once after they became a premium member, which was their first product out of the all the products available, what was their first order, right? So he wants to identify that particular item or that particular answer. Now let's proceed with answering this query. It's a little similar to the previous one. Now let's provide the okay, we want the customer ID as well. Customer ID and product name. And we also might have to work with the order date here, right? We want to identify the order date when they became the premium customer. So for that, let's go with order date as well. So we might have to place a, kind of a condition where sales start order ID is greater than or equals to members joining date, right? That's the clause here from sales, and we should be joining the menu table on product ID, and we might have to join the members table as well because we are trying to access the membership data, right? So members, and which is the common column between members. So customer ID will be the common one, customer ID, sales.customer ID, and members.customer ID. So just copy the members column, the table name here. Now we have successfully triple joined all the 3 tables here, and now we have to place a where command, where clause, where the sales.order date, right? So we had an order date, membership joining date, right? So we need to work with that. So the sales.order date is either greater than or at least equals to members.order date. So once they have become or became a member, they made they made a purchase, and that should be the one we are looking for. Now we should be grouping by customer ID and product name. I think this might cause a little ambiguous output, but don't worry, let's check. And we should be ordering by customer ID and membership purchase. There you go. So we have all the entries written here. To avoid ambiguity, let's add some details here. So this particular customer ID is from sales. So I want to specifically mention this column customer ID is from sales, and product ID or product name is from menu. So here it is, menu dot product name, and order date is from sales order date to eliminate any kind of ambiguity. There you go. And join on, this is fine. And finally, the grouping by part. So I want to make sure that there is no confusion here as well. So sales start customer ID is the one I'm looking after. So sales dot customer ID is the one which I'm looking after. Same here. There you go. Now let's execute this query and see the output. If we have any errors, let's resolve it. There you go. Unknown column, order date and where clause. Oh my god, it was not order date. So the members table does not have an order date. It had a join date, right? So join date. Now let's try again. So I think we had to aggregate this. So since order date is present here, we want to specifically make sure that the minimum order date after becoming a membership, after taking the membership, right? So we need to provide the minimum aggregation here. I think that was the error. Now let's try to solve the query once again. Non-aggregate column, Danny's Diner sales order date, which was not functionally dependent on group by. Let's try to alias this and use the alias name as first membership purchase, and in place of this let's use the alias name. I think this should solve. If not, let's try to rewrite. Okay, so we were supposed to use alias name here, not a problem. Now A and B became the customers with premium membership. So the first purchase made by A was ramen and curry and B was ramen and sushi. Now with that, we have solved the 6th question so far. And coming back to aliases, if you find your column name to be a little too complicated to be present on your data, then you can just rename it as the column name which you choose and use the keyword as. Rename this column as the custom name for your column. I'm proceeding with the next one, the 7th query. Which item was purchased just before the customer became a member? Okay, a little similar but quite opposite. Now this might or this shouldn't take much time, as we discussed before. Now the only change what we would be doing, according to my guess, would be it should be less than the order date, right? If you this is just a wild guess, just paste it here, and instead of this here, sales order date should be greater than or equals to members join date. If it is just less than members join date, I think we should be finding the answer. Let's try to execute and see the output. There you go. So that's what they ordered before becoming a member. Repeat. So that's what they ordered before they became a member. Now, Here we have the eighth query, which says, or which asks, what is the total items and amount spent for each customer or member before they became a premium customer? So we have about 3 more. Shouldn't take much time. Let's proceed with solutions to the eighth question. Now proceeding with the eighth one, what is the total items and amount spent for each customer or each member before they became a member? A similar one. So let's use the same query with slight modifications as requested by Mr. Danny. So we want to pull up the customer ID. Along with that, we want to pull up the product ID, but we want total amount spent, right? So we also want to know the total number of items purchased. So we will get that in sales data table. So instead of product name, we will go with product ID. And we are counting this, so the aggregation will be count. And moving forward, we have menu price. We want to extract menu price, right? So for that, we want to use an aggregate function called summation, sum of price. So to avoid ambiguity, let's provide menu dot price and close the bracket and sales dot customer ID. And now we want to join menu with sales. We have that here on product ID, and followed by that we want to join members with the rest of the two tables. So that can be done through customer ID, so we did that as well. And where sales of order date is less than members joined date, yes, that's sure, amount spent by each customer before they became a member. And now we should be grouping them by customer ID. I think that's enough, and we don't want to do anything else. Let's close the comment and let's execute the code. So there you go. So we have two members who became premium members of the Dyna, A and B, and before they became a premium subscription member, they purchased two products, and the total amount they spent on those, 3 orders from B and 2 orders from A, and total amount spent by B on 3 orders is $40, and 2 orders spent by A, $25 spent on 2 products by customer A. So this is what Mr. Danny is looking for. Proceeding further, we have the ninth query. So this seems to be a little complicated, but anyways, let's solve it. So now Mr. Danny wants to know if each $1 spent equates to 10 points. So for example, he spent about $40, customer B. So if each of those dollars is equal to $10, 10 points, then he must be having about 400 points, right? In that way. So if each dollar spent equates to 10 points, and sushi has, okay, another complication, sushi has 2 times the point multiplier, how many points would each of the customer have? So there's a small ambiguity here. Out of all the products available, if you buy anything, then each dollar spent on that product would give you 10 points, except for sushi. If you buy sushi and you spent like $2, instead of getting 20 points, you'll end up getting 40 points, double the initial amount. So then how many points does each and every customer have? So this requires a switch case. Like you need to have a condition where it needs to find out if the product purchased was a sushi or not. If it was a sushi, give 2 times the points. If not, then give the regular 10 points. Now let's proceed. So we need to select 2 things here, product name as well as customer ID. So select sales.customer ID. And when it comes to product, that's where the game begins. For that, we need to type up some use case, sum of, and now the case. We want to summarize all the points, right? So for that, we are using a summation function, and inside the summation function, we will begin with the use case. So case, and when product name is equals to sushi, since we are using text, we need to use quotes, SUSHI, sushi, then menu price, menu dot price equals to, sorry, into 20. So 2 times the points. Else, so as we discussed, if $1 is equals to 10 points, right? In the same way, number of the price, 40 into 20, 40 into 10, that's how it goes. So here customer B has spent $40 into 10 if it's not a sushi. If it's a sushi, then it goes 40 into 20, which gives us about 800 points. Else, if it is not a sushi, then else menu is the same thing. It should be 10 in place of 20. So give it as 10. And this is where the case ends. And you can give it some alias. So I'll name it as points, total points. And from which table are you selecting this? We are selecting this from the sales table. And we might also have to join some tables onto it. So I'd like to join menu table for the details on the product name. So from sales, and this is where you apply join, which table is menu, on what terms. It could be based on product ID. So take the product name, and instead of name, write it as ID. Product ID is equals to product ID, and which is like menu dot product ID for clarification and removing any ambiguity, equals to sales dot product ID, and we want to group it by sales dot customer ID. So I think we have it, customer ID here, and close it, select the entire query and run it. There you go. So customer A has 860 points, B has 940 points, and C has 360 points. So maybe if you want to order, you can also order by the points. Since we gave total points here, you can give order by total points in descending, so that B comes first, A comes second, and C comes at the third place. Now we are at the last query for the today's session. So the last query is about, in the first week after customer joins the program, including their join date, they earn 2 times the points on all items, not just for sushi. Okay, this is quite similar to the first one, but with a small condition. Let's say you pulled up the customer subscription program today, and from today on, for 7 days, the first week, if you get a membership, then within the first 7 days, if you get a membership, then you get 2 times the points on all the items you purchased, right? After the first 7 days, only sushi will have 2 times the points. So that's the small condition you need to follow here. So we need to have some dates manipulation here. You might want to have the date column here to place some manipulation on that to find out if the first week is there or not, right? So for that, let's proceed with the same query and make some modifications to it. So copy it, and we here are not just looking for customer ID, we're also looking for date. So everything is fine. Select customer, sales dot customer ID, some case, when instead of product name, we might want to copy this case once again. Okay, copy this. Enter. We are adding a new case. Maybe even in a bracket, but okay, let's anyway start with this. When sales dot order date is between members dot join date, so it kind of calculates the first join date, and this is where you provide an AND condition. If it satisfies both the condition, that's when you do it. And date add members join date So here you'll also pull up the interval function. So you need to set the interval for 7 days. So interval 6 days. Okay, I think it'll also take the count of, let's go with 6 and then try with the 7. Only then menu price will be into 20. And apart from that, more on, repeat. Apart from that, moving on, only sushi will have 2 times the product, 2 times the product price point, and everything else remains same. But if you are coming in between these days, the join date, the first joining date, apart from that 6 more plus days, the first week, which makes the first week, you get 2 times the points on each, repeat, you get 2 times the point on each dollar you spent, right? And repeat, right? And proceeding ahead, we are taking this data from sales and we are joining menu, and also we want to join the members data table as well. So join members, and you should be joining them based on customer ID. So copy it, sales.customer ID and members.customer ID. Fine. Where month function sales dot order date is equals to 1, group by sales.customer. Fine. So far so good. Now let's try to execute this query, and don't worry if we get some errors. We are just trying to guess. We just tried functionality using the interval function. Repeat. We just tried using the interval function by judging the days, right, including the join date. So here you can see date add. The first day of the week is members joining date, the day when it began, plus 6 days, which makes it 7 days. But no worries, just let's check. If it works, fine. If not, let's resolve it. That's how it works. Yeah, brilliant. The query worked, and that's how it goes. So in the first week, we have about 2 customers, A and B, and their individual points, right, 820 and 1370. In case if Danny decides to give away that 2 times the points for the first week. But initially, we checked the points were different, but here the points are totally different. Initially, B was leading, but now A is on the lead just because he joined in the first week with a plan where Mr. Danny wanted to have 2 times the price point, the pricing into 2 times the points. So that's how it pretty much looks like. And with that, we have come to an end of this session on the first use case on SQL fundamentals, which is Danny's Diner. And if you have any queries regarding any of the topics covered in this session, or if you require the resources like the code documentation or the resource space that we used in this session, and PPT, etc., then please feel free to let us know in the comment section below, and our team of experts will be happy to assist you at the earliest. Until next time, thank you for watching and stay tuned for more from MindMajix.